Okay. Let's see what's on Hacker News today. Yo, what's up? High structured concurrency in Lua. Intelligence and radical economic attitude? Nah. Geofencing will enable L5. Polluters must pay. Dilbert cancel in I guess it's a slow news for day. Yeah, it's a slow day for news. Making heads or tail of open source. Okay, this one's pretty good. Uh, oh, okay. Okay, mic's up. Hopefully that's better. Instinct building open source software. I don't know. I got bored of it within the first paragraph. I'm not really sure what the point he's trying to do. Uh, ooh, hash collisions and exploitations. Okay, this one looks more interesting. Getting an MD5 collision of two images is now trivial instant. Wait, what? What? Don't play with fire. Don't rely on MD5. Colliding any pair of files has been possible for many years. Takes hours each. This page provides tricks specific to file formats and pre-computed collision prefix to make collisions instant. Ooh. Okay, this is interesting. Goal is to explore extensively existing attacks on how weak MD5 is. It's the same file format trick can be used on several hashes, as long as the collisions follow by the same byte patterns. Okay, so this is about existing attacks. Alright, get a file to get another file's hash or give an implementation. Get two different files with the same MD5 hash. Flipped. Okay. Two different files with the same hash. 65-year core. Oh, I see. So this is just like a reversing the hash. Interesting. Okay. SHA-1 works with blocks of 64 bytes of text. If A and B have the same hash, then appending the same content as C will yield the same hash. Okay, so this is, was it additive, the additive property or whatever it is. Collision works by inserting at a block boundary a number of computed collisions based on what came before the file. These collision blocks are very random looking with some minor differences. These files are used to craft valid... Okay. These comment chunks are not real comments. They're just used as data containers that are ignored by the parser. Most of the time, a difference in the collision blocks is used to modify the length of a comment chunk, which is typically declared just before the data of this chunk. Okay, I don't get it. Hold up. So, okay, you have file 1, file 2, common layout. You're not doing it between two of them. I don't understand this. Okay. What the heck's it trying to say? Okay, they work with blocks of 64 bytes of text, and if you salt each one of the hashes, then if you salt each one of the inputs. Okay, so if A and B equal the same, if you hash A and B, then a salted A plus would equal a salted B when you hash them. All right. Collisions work by inserting at a boundary, at a block boundary, a number of computed collision blocks that depend on what came before the file. Okay, so each block is dependent on something that came before it. So you have block A, B, C, D, E in a file, and then if you want to compute the hash of block B, you rely on the hash of block A. Okay, these collisions of blocks are very random looking with some minor differences, and they will introduce tiny differences while eventually getting hashes of the same value after these blocks. Introduce tiny differences. Okay. So in other words, you can pepper in some value into the files within each block in order to get... Oh. Oh, okay, now I'm starting to understand it. So saying that, okay, well, if you take a file block by block, then each subsequent block relies on the hash of the previous block, right? But if you can insert data into like the 64 byte block, and then make each value the same, then you will eventually get the same hash. Okay, that's fine, but that doesn't tell me how to. But how exactly is that useful? Because that would require me to know the feeding of the initial key, right? Because if I know it's MD5 and I have the insert file, then I can always get the out. I can always predict the output. So what exactly is going on here? These differences are abused to craft valid files with specific properties. Okay, fine. File formats also work top down, most in byte by byte levels. Some comment chunks can be inserted to align file chunks to block boundaries, to align specific structures, to collision block differences. Okay, to hide the rest of the collision block randomness from file parsers. Okay, so this is just to obfuscate the attack as well. All right, these comment chunks are not officially real comments; they're just data containers that are ignored by the parser. Okay, that's fine. So, in other words, if you pepper in some amount of data, you will eventually arrive at the same MD5 hash. Fine. Oh, wait. It's 8 p.m. Alright, let me bring my client on and see what's up. Oh, no. Why does Zoom always log me out? That's so stupid. Open. Alright, cool. Oh, hello? Hey, what's up?
Hey man, how are you?
Doing good. How about yourself?
Good, good.
How's your practice going?
Good man. I went over the chapters you suggested in that worksheet in the prep doc, or no, not the prep doc, but the diary.
Uh-huh.
Yeah. So far so good. I've done the EPI quite a few times, so it did help not jumping to just going back to the checklist and not jumping to conclusions, right?
Right.
Because that was a common problem. And also, what really helped me is starting with a small example. Because what I noticed previously, I would start with like a big example, like you have a linked list with like 10 items, just bring it down to 2 and just work your example that way. So yeah.
Small. Remember to build the problem from the ground up. Start small. Start with examples that complete the very easy, simple, boring cases that you know what exactly it's supposed to do. And then from there on, you can build more complex stuff. It never goes the other way around. If you start complex, and then try going simple, it's terribly inefficient.
Yeah. Oh, yeah.
Okay, cool. So, did you notice like any particular issues when you were doing these problems? Any common mistakes that you're making? And can I see your check? And is your checklist in the doc?
1 second. Yeah, I created a separate sheet for that. Let me send it over to you. Or you want me to paste it into the prep doc, or just send you the link?
Here, let me paste into the prep doc. I'll put it under 920.
Okay. Okay, so this is... Okay, yeah, this is for the... Yeah, it didn't change much from last time, but I did add some items there at the end.
Can you highlight the difference?
Yes. Let's see. Yeah, I like this one. I really focus on this one. Yeah, this is a really one that I go back to a lot of the times.
Good.
Because what I found was I would talk about the idea, then try to code it up. But it's much simpler to have like bullet points and start off your idea that way rather than creating code.
Yeah, remember, always start with the idea. Remember, the moment you make code, it's the moment you commit to the idea, right? And
Mhm.
did you find that that kind of helped you?
Yeah, oh yeah, for sure, man. Basically, start simple, and then build up to a more complex argument. So that for sure helped me. Because what I was doing in the past is I would have a lot of things in my head, and my mind would just race, and I would kind of drop the ball at the end. So.
Hmm.
Mhm.
All right. So yeah, you have this engine, right? Examples, idea, bulletproof code. And you can always go back to it, right? It's like, oh, something's off. When I try bulletproofing it, and you may have noticed this, like if you come across, oh, wait, this idea doesn't work under this example or whatever, or I ran into some really mistake, you backtrack essentially, and then kind of go through your checklist of things like what went wrong, what can I do, etc., etc.
Mhm,
I think you probably noticed that.
mhm, mhm.
Mm. Okay, so I mean, to catch all the details, how can the input be modified? Yeah, more. I would say more specifically, does your input handle all the possible ways? Does your code handle all the possible ways inputs can be managed and stuff?
Mhm.
So I'd be that's what I think you should really be thinking about when it comes to all these. So
Okay.
all right. Other than that, I think it looks fine. Not much has changed. How has your hit rate been for practice? Do you feel like you're getting faster and better and more accurate at these, or do you still feel like you're like struggling to get the correct answers or not understanding why exactly the book got the answers they did?
So far, those three chapters, I done quite a lot in the past. So I did manage to get most of them. The one that I struggled with was let me see. It's like build a list, build a tree from in order and a pre-order traversal.
Yep.
That's the one that I struggle with. So yeah, the way the book does this is like they have an index on the pre-order because then they look at the example. Okay, all the nodes are going to appear to the left for the in order traversal, and all the nodes for a particular node are going to appear to the right. So then they traverse and they basically build up on that idea.
Okay. So all right. Yeah, that's not. I think I gave you the serialize and deserialize a general and array tree. That's pretty much more or less the deserialized portion anyway. So all right. And you feel like you're can you give me a problem that you felt like you failed on at yeah, the ones that show me the ones that you failed on.
Okay, let's see.
Give me one that just kind of like stood out in your mind.
Yeah, from today I did is height balanced.
Okay.
Um,
Did,
so for that one, let me see if let me see what problem it is on the API.
okay.
Is problem number one. I can send you my problem log too if that helps for this.
Yeah,
Um,
I think that would help.
okay. Yeah.
My point with this is that I want to see how you're evaluating your own mistakes.
Okay. Okay. The Zoom chat. I'm gonna send it over on the Zoom chat. Yeah, if you search for height dash balance, it should be that entry there.
In where?
And I send you the document in Zoom chat.
Oh, Zoom chat. Got it. Got it. Let me take a look. Okay, cool. Got it. And this one is height balanced, right?
Mm-hmm. Correct.
Okay, so let's see. Breadth first at every single node, compare the height of the tree. All right. If the difference is greater than 1, return false. Okay, there's an efficient way to do this for every single node. Repeat work. Yep. So at every single, so you're going to iterate through every single node and do breadth first search for.
Correct. Yeah.
Okay, got it. Yeah, it's a little bit abstract, but I get the point. And you correctly identify, hey, yeah, for every single node, I have to do a breadth first search. And the moment like some of the heights start being different, then I get fucked. So yeah. So then how do you find the height? Right. All right, so then height means that height of joint, you will do many comparisons, correct. So, okay, so then if node is none, you handle the node. If there's no node case, return.
Yeah, I think here I'm defining what the height function would be, and this would be called at every node.
Okay, sure. So you're going to be looking at every single node, and then you're going to be looking at the left and the right. This still feels, when I look at this, I see you write this, yeah, I get this is like one part of the problem, and you're kind of reusing it from this part. I get it. Okay, yeah, you're reusing it from that part because that's the one thing that's consistent. Fine. Is height balanced is true. Basically, tree traversal that you call height at each node. Okay, so then you're going to see if height balanced, and just see the left. If the left is height balanced and the right is height balanced. But then you also have this absolute here. So
yeah.
So the thing is that, are you returning true false or are you returning a number? Because this implies a number. The naming implies a Boolean.
Oh, I see. Yeah. Yeah, I think I picked a bad functioning for this one.
Okay, but what's it supposed to return?
It's supposed to yeah, it's supposed to return. Yeah, it should return if it's balanced or not. But here I kind of mixed up the two, the height and the Boolean.
Right. Okay. So this is where I would say the first mistake is declare, or what the fuck your function should do.
Okay.
You need to define that. So that's something that popped out to me. I get the idea though, is that if you could find a way to like return essentially both that information, and so if the left and right is height balanced, then you would want to return. Then you would take the difference of their heights, and if those heights aren't balanced, then sure, and then return 1 plus the max of left, not left plus right. Why plus? Why is it plus?
Oh, sorry. Yeah, that's a mistake there. It should be a comma.
Yeah. I think you recognize that, but remember, everything you write means something. So, if the interviewer says, "Uh-oh," like you don't want him to catch your own mistakes. You want to catch your own mistakes and correct them. Yeah. So, okay. Basically, keep iterating. Okay. So I think this. How can we terminate early process and stop processing? Yeah. So is your balance? Can you return more information? Yeah. Okay. So your idea is correct. Yeah. So.
And this is where I was doing examples to go to the most optimal way to do this.
Shit. I see what happened here. So, your tree traversal, right? So your count is that's fine. You take a look at height balanced. Is height balanced? And then return is balanced left, is balanced right, right? And so here you decide is balanced left, is balanced right, right? Okay. So then now I look at this. I would say the thing that stands out to me, and if this was me, I would be like, okay, is balanced left and right, right? That's pretty similar to what you got going here. So that would have been a key sign. Hey, wait a minute, I can probably just combine this. Especially if the ideas behind them are really similar, right? All I'm doing is I just need the left to be height balanced, and if it's not, it's false, right? If it's right's not height balanced, then false, right? Otherwise, this would always be true, and so you would return true here, because like if either one of them is false, then the and becomes false, right?
Correct.
So just by this logic alone, this must be true. So, you kind of it's if you just think about it a little bit more about the redundant work for if statements, you would have realized that hey, this idea is very similar to what you got going in here.
Yeah.
So.
Yeah, and the strike through, that's what I had. That's what I did after my review on this. I realized that I'm traversing the tree again, which takes us back to our original solution where you're looping this tree again.
I wouldn't say, if you think about, I wouldn't say that. I would say that if you start with the root and then you go left and right, you're actually doing the exact same thing in two different subtrees. So it's not necessarily runtime inefficient as much as it's code inefficient actually.
Okay.
Because if you think about it, the left subtree and the right subtree are independent, right? And if we magically wrapped it into this function, then you would still have this left here and this right here. right? You'd still be doing exactly the same thing here. So let me just highlight these for you. Technically speaking, these are not these are pretty much the same. The only thing I would have done is, you know, like you said, after this I would have just done this. If not high balance, return false. That's it. All you have to do is just really recognize that, hey, this can fit in one function, do one, and these will do one thing, right?
Yeah, that makes sense. Okay.
Okay, so then this is balanced, and then yeah, then you would just check is balanced and do return those two items. But you get the idea roughly. That is what I would think the mistake is actually. You were pretty close. It's just that you probably could have thought about it a little bit more. I don't know what, but the thing is that why did you make the root a special case? I think why did you make the very first iteration a special case? This was telling me.
Because I like when I think recursively, I always want the base case defined first.
Yes.
Because you don't want to keep looping, right? So that was my reasoning there. But yeah, let me write that down. I should think more of like the base case.
I think okay. I'm starting to see what happens. The moment you mentioned base case, I think you have a misunderstanding of what exactly the base case is. So let me clarify this. So, for instance, if I have like a tree X, and then here, and let's say YZ, right?
Yeah. In
your function here, your base case is actually the state of the node, and this is what makes tree problems very easy. Is that hey, I have this this node here, right? And it can either have 0, 1, or 2 children, or it could be null. So the very base case is, okay, I am at a node. That's it. And this node is either equals null or not null, right? And then, so this is like, so you've handled the not null case, right? I mean, sorry, the null case here. So let's eliminate that. So that's the very first, that's one of your base cases, right? Now you arrive at a not null. The question now is, okay, now this is not null. Then what are the variations of not null here? You have X, and then you have X with, you know, Y. And then you have X, and then YZ, right? And those are technically the recursive cases. So the recursive case.
What about the case when it's just like a right tree, right? Do we consider that as well? Like if it's X.
I mean, why the hell not? Yeah, I mean technically, this is what's called symmetric, right, around the root, because it doesn't matter if, at least by the nature of this problem, it doesn't matter if it's YZ or ZY. It's just a binary tree. It's not like I don't think there's any restrictions on like, oh yeah, this is like has to be in this order. You know, left has to be less than right or whatever. Based on this, it's like we're pretty much guaranteed that YZ and ZY should be reasonably handled in the exact same way. Because if you look at this, it's pretty much copy pasta code. There's no reason we would treat the left child any differently from the right. So the YZ ZY is, I mean, technically technically you are right. I'm just kind of skipping the step of like, hey, it's pretty obvious that ZY and YZ should be handled the exact same way.
Okay.
So, yeah. So then you have this. That's fine. So really, when it comes down to it, it's just really this base case here. This is the base case. This is the recursive cases, because you're relying on the output of the self call here, right? And then from there on, then you composite it into another base case. Does that make sense?
Okay. Yeah, that makes sense.
It's not, oh yeah, let me just start things off and then do recursive and then make that its own thing. It's just the number of cases. No, let me rephrase that shit. That was a fucking terrible way of explaining it. When it comes to recursion, there are only some, when it comes to base cases, there is no dependence on a call to itself.
Okay.
That's what I mean by base case. Null does not rely on additional calls to is balanced. But determining the state of Y, because you know Y might be a null case. It might be its own tree, right? Because every subtree of a tree is a tree. So that's where this comes from. And so after that, once you composite this, I have some state of Y, I have some state of Z. That's what this function is, and then I'm gonna bring those together to handle my other case. That's what this means. Does that make sense?
Okay. Yeah, that makes sense.
Okay. So once you think like that, it should be a little bit easier. Another way I find that people can understand recursion is that if I replace this with a magic function, magic black box function, and call it is bounce 2, right? And let's suppose that for every single input, that it does the exact same thing that is bounce does. That's exactly what this is. That's essentially what recursion is. It's just, hey, this function is this function. It's just written in a different way. So that's the way you should handle it. And all that's left is, hey, make sure you can handle all the possible variations you got going here. And then once you handle all the possible variations, then this self-fulfilling prophecy of is balanced and is balanced 2 become equivalent, and that becomes true.
Okay.
Okay. All right.
Okay, so
go ahead.
Going back to the base case, I got a bit confused here. So
yes.
The base case is your stopping point, and like basically how all your basically you start with something big, and you're basically breaking it down to small steps, right? Until you get to the end. Is that what you mean by that?
So when I say base case, I mean something that is contained within itself. So for instance, again, if null is a base case because I do not rely on any subsequent calls to is balanced, right? If
I see.
Because a null root is that balanced. Yeah, it's binary, yes or no. I don't rely on an additional call to is balanced to get it, right?
Mm-hmm.
But let's say I take a node with one child, right? That's not necessarily a base case in and of itself, right? The y is going to need to make a call to is balanced, right? But once I have that, then I can composite it with this value of x.
Yeah.
And by logic, x cannot be null. So we're dealing with a not null case. We're guaranteed that x has some value. So xy would be technically another base case, or I should say another case. I think it's just easier if I say case, because that way I don't confuse you. It's just another case where one portion of it is reliant on y. Now, technically speaking, this could be the equivalent of where, let's say, z and where z is equal to null here, right? But we already know that z null is already handled for us. So technically, just on that technicality, you already fulfill right as well. Does that make sense?
Yeah, that makes sense.
But you shouldn't. But looking at it from the standpoint of x, you shouldn't care like what that value of z is. You just know it's a node. What it could be like 1, 2, 10, and like a million or null. You don't care. You're just throwing it into this magic function that will give you the value of whether or not this is height balanced, and whatever data you decide to spit out. And then from that data, you can repackage it, read it, do whatever in order to figure out your answer. So in this case, if z is not height balanced, then x can never possibly be height balanced.
That makes sense. Okay.
That's what it means. So hopefully that clears up a little bit of recursion for you.
Yeah, for sure, man.
I think let's do a recursion problem today. But yeah, like I think the biggest that's probably one the mistakes here are, hey, maybe look at if your code is a little bit too complex or it looks a little repeaty, and also get a little bit better with recursion. I think that's the two lessons today.
Okay.
Anything else you want me to look at before we start?
So I did do what was it? I did let me see. I'm looking at the diary. Right there. Yeah, man. So I did Facebook Messenger. Do you want me to send you the link there?
Sure, why not? Wait, hold on. I got to use the bathroom. The pre-workout's flowing through me. God.
Yeah.
The caffeine, man.
It's like creatine.
Okay. All right. Let's see what we got.
I sent it on the Facebook. Zoom chat.
All right. Let's see. You sent the Excalibur. Great. Okay, let's take a look. Does that... Oh, you... this is YouTube, and you put Facebook underneath?
Oh, sorry. Yeah, something was wrong with the Excalibur where it kept. Yeah, it's at the bottom.
Okay.
Yeah.
Got it. Design Facebook Messenger, WhatsApp. Cool, cool, cool. Okay.
Can you share your screen for this one, please?
Oh yeah, sorry about that.
Thank you, thank you.
All right, can you see it?
Yep.
Cool. Let me load up the grokking one just so I have the key in front of me.
Mm-hmm.
Okay. Okay, cool, cool. So users should be able to send messages to friends and contacts. Send to offline users, sure, why not? User coming back online should be able to see messages that were sent offline. Yep. Users have status on and off. Nice to have. Send photos and media. Sure. Are we assuming that... Okay, I guess the add and remove friends block... How about blocking people?
Oh, yeah, I didn't consider that phase there.
I mean, it's okay. Because a lot of these things, there's a lot of ways you can go with it, right? But then you most likely what you're gonna do is you're gonna have to strip it down to the very basic stuff. So one-on-one. So look at this, you should be able to one-on-one conversations, keep track of users, persistent storage, yes. Non-functional 9 uptime. It's okay if user sees a message after a while. What is that while though? So it should be near instantaneous, but being off by a second doesn't really fucking matter.
Okay. So when we say like AP, like 5 seconds, is that a acceptable answer?
Yeah. I mean, again, it's like based on fuel, right? When you're designing a lot of these products, a lot of them is going to be based on what you think the user is going to want, or reasonably expects, and a lot of that is down to like personal judgment and whatnot. Some people really, really need the instantaneous time. So, for instance, if you're on like, Ventrilo or whatever it's called, like back in the day, you kind of are going to get pissed off if your service gets delayed by 5 seconds. Because if some guy says rush B, and then you're starting the game, and then 5 seconds later someone says rush B while you're rushing A, it's just going to be like, what the hell? But
that makes sense.
Yeah, so in that case, if it's gaming, then you almost want it like real time, like literally 100 milliseconds or less. But if it's like something social, then people don't really care. So it's like, again, the best way to think about it is what would piss off a user.
Yeah, if this was Discord, this would not fly.
Exactly. So you get the drift. I love the whole invert heuristic because it's so much easier to think about what the user would not tolerate than what the user wants. So, our system should be highly... So you pick AP over CB if we don't see the user... Okay, fine. But they pick C. Interesting. Should be highly consistent. So they say that everyone should be able to see the same message. And you say AP because you don't mind if everyone has different messages for a while.
I guess my heuristic behind this was you send off your message, your user might not see it right away, but they'll see it in a few seconds there.
Okay. Let me think about... Yeah, I mean, I get your reasoning. It's like, oh yeah, if some of our nodes go down, then we can still operate, because that would contribute to a higher uptime. But the thing is that the question now becomes how long does it take for these nodes to restart? So if we are like delayed by like let's say a minute, that could potentially be okay. But if we're delayed, but in this case you kind of said only a few seconds. I think that not every node can restart that fast. I think that's probably the thinking here. I get that. Oh yeah, that's your thinking, but I think it's just wrong from a judgmental perspective.
Okay.
So your reasoning is right. It's just that your instinct is wrong.
Yeah, I think also because it has online and offline capability, I think that's what kind of led me to this. Like, because if you send it to an offline user, they're not going to get it right away. They'll get it eventually. So yeah, that was wrong there.
Yeah, that one's a little bit tricky. I mean, again, I don't blame you, but if you just think about like how long it takes for a node to restart, then
Well, yeah.
it can be quite a daunting issue. So that's kind of where that's a little bit messed up there. Read write ratio 1 to 1 basically. Yeah, I think that's pretty accurate. Unless you start doing group chats and stuff. But other than that, I think you're pretty much on the ball for the 1 to 1. I think.
Yeah, yeah.
And then they also do group chats. So yeah, the 1 to 1 ratio would have immediately triggered a hey, do we need to handle group chats sort of thing. But other than that, it's fine. I think what you came up here is okay. Let's just assume 1 to 1 for now. Okay, so now you're defining schema. All right, wait. Did you define TTL by any chance?
TTL for what?
Time to live. How
Sorry?
long should the data live? Should we?
Um,
Yeah, go ahead.
I basically said they should be on forever, basically.
Okay,
Yeah.
that's fine. But definitely want to keep that in mind. Don't. Do I see it here?
I don't know if I mentioned in the bottom.
Yeah,
Let me check.
I don't see it, so I'm gonna say it doesn't exist. But yeah, it's
Okay,
very
okay.
important to write that down. How long should the data live? Because like messages are being sent back and forth every single day. Your data is gonna blow up. So the most obvious pain point to me is, hey, yeah, what about messages from 7 years ago?
Or
Anyway.
users that don't come into the site often, right?
Yeah. That's also one as well. But maybe like users who even use the site often and then want to pick up a conversation that they had 2, 3 years ago. It's some weird cases like that, but it's things that might again piss off a user. It's like if we don't have it. So it's like if I look back at my chat logs from high school, I'd be glad to delete them, but like everyone's cringy as fuck back then. But I definitely would want to expect to have that. So okay. All right. So then now you're gonna have we're carrying our data into one database, slow service. Yes, that's fine. User contacts and messages. That's fine. I don't mind this. Okay. So how do you need to send to offline users? Yes. That's a good one to call out. What would be the best way? Although you probably need to call it the data flow, right? Because now that you have these two databases, the question now is like, okay, how does this interact?
Okay.
Okay, so I wouldn't go after the offline case yet. I would just handle the online case. So the flow here would be user sends a message to application server updates the user status or something and with a timestamp. And then sends them and then writes the message to a database, right? And then from there on, it will just send it back to the other user on side B with a push notification. And then you can handle the cases, and this is assuming that both of them are live, right? Look at the exact same thing, exact same message. And then now you have the unhappy case of like, okay, what happens if some of them are like offline, some of them are not looking at the app, right? So that's basically where you're gonna that's gonna be an important step. Anyway, so then now it's like you have that push or pull model for this. Okay, so yeah, users offline, message stored in cache. Once the user comes online, we have a daemon that constantly pings. Hold up. You need a service that tracks. Yes, you do need to track that. If a user is offline, a message that is sent stored to cache. Okay, so if a user is offline, they don't actually get a push notification?
I see the mistake there. Yeah, my reasoning for that was they're offline, so the message is going to be marked as let me see, it's going to be sent as on hold, and then once the server sends it to them, it's on receipt. And then once they see it, it's going to be marked as seen.
I see. So if the device doesn't like ping the server for whatever reason, then they won't get a push notification at all. Okay.
Yeah, I missed that path because at the very end it talks about push notifications. That's something I should have talked about like when users are offline. Because right now the way it would work is they open their app and they see a bunch of messages like bing, bing, bing on their phone.
I see. Yeah, so I understand where that line of thinking comes from, but if we think about like from a user, like right now my phone is on sleep, right? Should that qualify me to be offline or online?
Offline.
Okay, so that means that I'm not going to be able to receive any push notifications just based on your design.
Correct.
So again, it just goes back to what's the end user you're going to expect, and how do you model that? So that's probably the mistake here. So again, I understand where you're coming from, but I just threw one user case at you that kind of contradicts. So again, it's about like, oh, I come up with this idea. Let me do it. Let me spend more time punching holes in it. Like it doesn't have to be like super complex. Usually, it's gonna be like one or two simple cases, and if it survives those tests, chances are it's gonna be pretty good. So I'll spend a little bit more time just punching holes through whatever idea you have. Okay. Yeah, just again, one or two cases to prove that this is the right way to go. If it starts getting to the too complex or too hard territory, then you might have spent too much time on it. But you know what I mean. It's just it should survive some very simple ideas and tests, some very simple use cases. Okay, so when a user online, message will be sent to them. Message is acknowledged from user. Mark this message as received, and once you've seen the message, we will update the message status. Okay, that's fair. That's fair. If the user, we mark this message as received. So in other words, when if a push notification goes out, then that's when it gets marked out as received, right?
Correct.
Interesting.
Yeah, I think because I think in WhatsApp, if I send a message to a user that's offline, they won't get the push notification, right?
Okay.
They'll get the messages once they're back online. This was like this analogy was used from like traveling overseas, right?
Okay.
Not overseas, but outside the U.S.
Okay.
So that's how I would see this service interacting.
I see. I'm going to label that as a too hard pile because let's think of it this way. If I'm getting on a flight to Hong Kong and I'm 13 hours in the air, right? And then you say that, and you send me a message, right? That for 13 hours, it's going to appear that the message wasn't received. Oh, so this is the blue check. You're talking about like received or read. Let me ask that.
Correct. Yeah. It has like the single check mark, like if I send it to the server. And then once you get it, it'll have the double check mark.
Yeah, it'll be double gray, as long as it hits the server. And then it'll turn to double blue when it's red, right?
Correct.
So that is the issue, is that if it hits the server, but I'm up in the air in Hong Kong, do you want it to be single check or double check?
Single check.
Okay. Then then corollary to that, how do I know my message was successfully sent?
That is acknowledgement from the server, the single check.
Okay.
Like I'll send it.
Okay, sorry, go ahead.
So I'll send the message to you. The server grabs it. It has a single check mark.
Oh, I see.
So once you're back online with your Wi-Fi or your cell network, you'll get the message and then it'll have the two checks.
Interesting. That's not intuitive to me, but I understand where you're coming from. If you can explain that, it's not intuitive, but then I'm gonna probably. If this was me on the other end, I'd be raising an eyebrow like, okay, let's see how you roll with this and how you handle that.
Okay.
Because a lot of these things, remember, push notification is not a guarantee, right? It's just fire and forget. So, in other words, you're relying that eventually, once the user comes back online, that they will download all those messages, and then you mark it as received. So that's a little bit finicky to me, just based on my intuition. I would much rather have single check represent, hey, we're still trying to send this, double check gray to mean, hey, it hit our servers, the user has yet to download it, and then if the user downloads it and it hasn't read it, it's still going to be double gray. I would cover that.
Okay.
I would cover that use case only because ensuring that the message was sent versus because what you described is that there's no distinction between a successful send to the server and an unsuccessful send to the server.
Okay,
and that's a little bit weird. Because if you think about like the pain points of like sending messages, is that hey, how do we know the message was actually received by the server versus how do we know the message was actually received by the end user at all? So you kind of blurred that distinction. That's a little bit. Yeah, but I think that's versus like it hasn't been sent.
Okay.
So that's the use cases get a little bit blurred there. Do you understand? You kind of understand where I'm coming from?
Yeah.
Again, it's not necessarily wrong. It's just a little bit strange, but it's as long as you can reason it, and you have the proper infrastructure to handle it, then whatever. That's all I'm gonna say. But I would try to lean towards something that's a little bit more established. Anyway.
Yeah, I think what my thinking was like a few years off. I think my thinking was a few years off, right? Because I kind of like dismissed the whole push notification route.
Yeah. So, yeah, but push notification has been around for a while, but it's important. At least now you made the mistake. Now you know you won't make it. Okay, so then let's see. User sends, holds, received. Okay, this is the user flow you're seeing. Okay, fine, fine. All right. So then, what's the next obvious issue?
Throwing a bunch of users at this, and how will you handle all these online users at one time, right? Because it's not just one or two few users you're dealing with here.
Okay, sure. Let's suppose that that's one way to think about it. I would say your issue already happens when you start hitting 5 or 10 users. Do you know what that is? Your database, the amount of messages you have. Because if you think about like user, again, think about user interactions between people. They're gonna send like 100 texts per minute or whatever hell, right? And between 5 people, like if 5 people are having the conversation by network, 5 plus 4 plus 3 plus 2 plus 1 divided by 2 or whatever, conversations that are happening. So it scales exponentially. The number of messages that you have scales that way. No, not even exponentially. It's factorially, right? No, not factorial. It's well, you get the idea. Is that it's near exponential or whatever the hell you want to call
blow up? Yeah. These guys, what they did is they jumped in to talk about like wide column databases and what's best for that. So yeah, that kind of threw me off there. I think they talked about HBase, that it's built on top of HDFS. So I put that on my notes to read into that for if that discussion ever comes up.
Okay. Wait. Oh, is this the is this under 5B, the storage and retrieving messages from database?
Let me see. Cracking. Yeah, if you search for HDFS, it should show up.
Okay, HDFS. Hadoop distributed file system. Ah, okay. So parallelized processing of some kind. The hell?
Or sorry, HBase.
HBase.
They talk about HBase and then
key value NoSQL database that can store multiple values against one key into multiple columns. Okay, I'm going to tell you that the details of these databases are a little bit outside my realm of consideration. I would, if I had to choose a database from scratch, I think NoSQL makes a lot of sense because you're going to be, you're not going to do a lot of joins. It's going to be unstructured data. But most likely, you're going to be grabbing data by a particular user in a time range.
Correct.
So you might be able to get away with SQL, actually, by that logic. Why key value? That's the interesting part. Why do you need? Why does key value work here? We cannot use our. Why would you want Mongo? Mongo is for documents. You would not have to read or write into them every time. I see. Okay, go ahead.
For the connections, right? I think they use a key value for that.
Do they?
The online connections.
Hold up. Let me see. So maintain the sequence. Okay, so they ask sequence of messages. Okay, so you just order by timestamp. The timestamp is just going to be an issue later because time sent from the the phone versus time received on the server. So ordering is going to be interesting. When chat receives a new message and you store in the database, two options: start a separate thread, which will work with the database to store the message, send HTTP request to store the message. How to efficiently work with database connection pool, retry fail requests, where to log those requests when they failed. Okay, yeah, so you need to be able to handle like failure to write to the database as well within the internal system. Which storage system should we use? We need to have a database that can support a very high rate small updates and fetch a range of queries. This is required because we have a huge number of small messages that need to be inserted and queried while the user is most interested in accessing sequentially messages. Okay, sure. We cannot afford to read or write a row database every time user sends a message. Okay, so my idea got shot down because what I literally just described, they said, oh yeah, don't read or write to a row every single time a user sends or receives a message. Okay. High latency, huge load on database. Yeah, that makes sense. Can be met with wide column databases. Column oriented to store multiple values. Okay, it says multiple values against key into multiple columns. But what is that one key? The conversation? I guess.
Yeah, I don't understand what that would be. I mean, I understand the date time and the text. And the user, I guess it would be user A to user B, right? And then it has like the timestamp.
Yeah.
You look at it that way?
The thing is that the key... I'm guessing, I think based on what they're telling me, I think it's just that, hey, If it's wide column, then it's just going to be the conversation ID is going to be the key, and then the messages themselves are going to be the values. And you got multiple values for in there. So I guess that's where the wide column comes in. And if you append to the front of the database for the wide columns, then okay, I guess that makes sense. It's hard. Again, like this one's a little bit out of my depth. I'm not gonna lie. But you kind of need to come up with some reasoning for using one type of database over another. But this requires you to kind of understand how these databases work. So it's like it's a little bit of the experience, right? So I'm gonna say that it's a little bit hard. Did you at least try to come up with an answer for the type of database you want, or at least
no, I don't think I discussed that.
Okay,
I did discuss partitioning and all that stuff, but no, I didn't choose a specific tag for the DB. Because when you create a message, I thought that would be a row in SQL. There's really no other people that are going to be trying to lock that row at the same time, so that threw me off there. So.
Yeah, I understand. And you made the same mistake as I did, so. But then again, it's pretty obvious. Like, hey, every single time you want to query, you send a message, you don't want to keep writing to the database just to do that. You kind of, and so they kind of say, oh yeah, we have a buffer in memory for the messages, for the most recent messages, and once the buffer is full, we dump it to a database. Yeah. That makes sense. So the reasoning is pretty sound.
Okay.
But I think if you just describe the characteristics of a database that you would want like that, then I think you would be fine. So I would say try to describe a database that's similar. You might not have the name by name, but you should at least describe the characteristics of what you'd like. And this is pretty reasonable. Okay. And I think you could have reasoned it out. So if I'm doing the whole exercise of, hey, let me rethink my thinking and whatnot, I'm going to ask myself, hey, the most recent messages are more likely to be accessed very, very quickly, right? And so I'm going to need to be able to cache that. But then once I've written enough messages, then I need to start writing out the earliest messages to the server. So I can either do that in sequentially, like as a stream, and then evict them from cache as they, after the 100 messaged or after some time, or I can dump it in a buffer.
Okay.
So that's probably the way I would describe it. And then the interviewer asked me which one would I pick. Honestly, I would have picked the stream, to be honest. At least I'm writing as a buffer. I mean, that reduces the amount of writes for sure to the database. And yeah, actually, if I think about it a little bit more, it's like, hey, well, my limitation is I don't want to choke the database with all these different writes from stream, and I want to be more efficient. Then writing from buffer, writing a full buffer would be the way to go.
Okay.
Yeah, I mean, you kind of see like the logic of how I
Yeah.
So you understand that.
Okay.
And use the status, broadcast 2 delays whenever the user does not go offline. Okay. So then now let's go back to this one. If a message sent to a user online, just send it directly later. Otherwise, queue low priority so it can save for database for record purposes. Okay, so you're actually putting a high priority and low priority queue, actually.
Yeah. For like offline users, it would go to the low priority queue. Because they're not going to see the message right away, so it's okay to take your time to save that.
That's not a bad way of doing it, actually. That's pretty clever. And I think based on your reasoning before, it's like, well, users offline, we want to handle the interactions between the highly active users first. That's not bad. I think it's actually pretty clever. Even though I'm pretty sure the book doesn't do it, I have actually I don't really have complaints about it, except the only thing I'd be asking is like, okay, how do you manage the queues? How do you promote? What's your algorithm for selecting messages in queues? What happens if in the case of power failure, how do you recover messages from the queues and put them back in? Then the response you would have to probably put is like, okay, well, these messages, each message itself at the time that it was sent has a status of low priority, high priority. So restoring the queue actually ends up becoming your issue. So I would definitely want you to start, like I said, the test here is like punch holes in your idea.
Okay. Yeah, I guess for that one, you basically just have like a standby replica, right? Or a standby queue.
Standby queue?
In case one of them, like a queue, like a secondary queue, right? In case one of them goes down, the other one will replace it. But then it gets hard. Yeah.
It's hard because I think that's hard. I know Reddit tried something. Not Reddit actually tried something like this, and it got very, very complicated for them. To me, that like that's a sense of like, oh yeah, it's too hard. Okay, so let's say because that means you have to maintain two queues. You write from one queue, and then when that queue is done, you will evict from both queues.
Yeah, yeah,
And so you have two synchronous queues to maintain. That means you have double the amount of memory you're consuming for the messages, and there's a
yeah,
lot of messages. Your
yeah,
memory
yeah.
blows up. And then also, God, I need to pull up the Reddit system design thing again. I know for sure they talked about this. Remind me before we go. Oh, for me to send it to
Okay,
you.
okay.
I
Okay,
know
okay.
for sure they encountered this fucking problem.
Hmm.
I mean, it might be an infosec talk actually, but okay. So data partition, time range, message ID, user ID, random, but we have to query more servers. User ID, not all users. So what did you pick for the data partitioning?
I went with the message ID, but
Okay.
that was wrong. The book chose user ID
Yeah.
because a user is gonna go and they want their messages right away. They don't want
Yep.
to query a bunch of servers.
Right.
Um, mhm.
That
So
makes
yeah,
yeah.
my reasoning for that, I said, okay, you want uniform distribution, but that's not the right way, as opposed to the last problems I was working on.
Yeah, you kind of did the oh yeah, let me use this thing because it worked before sort of thing. It again, punch holes in it. So it says, okay, let me pretend I'm the user. I am loading all my and I'm booting up the app, right? I'm loading all my messages from my 10 friends, and so all the messages that I'm downloading that I would get when I was offline. Oh, person one's message. One of these messages lives on shard one. One of these messages lives on shard 10. One of these messages live on shard 15. Whatever. So every single user is gonna be querying some amounts from different shards, and that will slow us down. That's not efficient. So this is what I would highly recommend focusing on punching holes. I think
Okay,
for both your system design and for your leak code, I'm starting to see a pattern.
okay,
You kind of just do the fire automatically and do it a little bit mindlessly. I think yeah, just take like 2 seconds to punch holes into your idea before you commit to it. I think that'll help you
okay,
a lot.
okay, okay.
Okay. Other than that, I think that's pretty much it. Chat server dies, replication, message lost, good, bad, did more depth. Yeah, I mean, don't get me wrong. You're getting better at this. It's just that again, some of the reasoning is a little bit weak.
Okay, okay.
But if you kind of went and spent a little bit more time just trying to bulletproof it, I think you'd be good.
Awesome, awesome.
Yeah, it's starting to get there. It's starting to get there. We have 8 days, so
Yeah, yeah. So it's the next Friday for Amazon, and for the Google one, I still haven't scheduled it. What do you recommend on that one?
it'd probably end of October. Probably the I think like I said, you're starting to get there, and if you queue it up at this pace, we can make it.
Okay.
But yeah, I would say just make sure that you would keep up the high level effort if we can.
Yeah, for sure, for sure.
All right.
Yeah, I did take a little break because I thought I was in the brink of burnout, so I did slow down one day or so.
Okay, that's fine.
But yeah, everything's good now. So.
All right, one day is fine. I don't mind. I would. Yeah, don't worry. We're gonna hit the burnout time in probably in like two. I would say by week 6, week 7 is usually when the burnout starts hitting in. For real. But we'll manage it when we get there.
Okay.
Okay. So in the meantime, let's go ahead and do a problem. So let me go ahead and open up. Let me get your problem sheet out. Okay, here it is. Give me a minute to set up everything. And then let me add the timer. Yeah, I think we might have time for both a system design and a leak code if we're lucky. We'll see. Okay, so you got a timer here. Okay, cool. Let me add the Sublime text. And then let me load up a problem for you. And it's good. Let's make it a recursion one. Root to leave with a specified sum. That's a good one. This one actually might be a little bit simple, but let me see if there's another one I can give you.
Yeah, I did. I did the N Queen's placement this weekend.
Mm-hmm. Done this one already. You did this one already. Yeah, I already gave you this one. Not this one. Wait, how good are you with dynamic programming?
I did like 2 or 3 sections on Grokking DP.
Okay. Then we'll hold it off for later. I want you to improve your recursion before we get to things before I torture you.
Yeah. I didn't get to the chapter that deals heavily on strings.
Okay, that's fine.
To do.
All right, so let's go ahead and do this problem then. Let's start the timer and wait, where'd the timer go? Oh, there it is. Cool. So I want you to find a root to leave with a specified sum. So if I say punch in a sum of 38, right? There are 2 possible routes for me to go. I go 10, 28 or 10, 13, 15. And my output would be able to spit out both. Does that make sense?
Mm-hmm. Wait, so if you go through the 15 route, that's what? Oh, because you can do negative numbers?
Yes, there's a possibility that there might be negative numbers in here.
Okay. Okay, were you gonna say anything else?
Nope, it's all you, dude.
Okay, so you start off at the root of the tree, you go to the leaves. Okay, so what I'm thinking here is if I start off with my initial sum, the end goal is to get to a sum of 0 when you're at a leaf.
Okay.
So as I'm traversing this tree, okay, so as you recurse, you can. Okay, so as you recurse, you modify your sum, right? That's an entry into your recursive function. Then, because I'm looking at. Okay, so let me draw this out. Just to draw an example, 28. So I'm just looking at this case, right? If I go to the left, so initially I start with initial sum, right? I start off at the root. I subtract value at current node, and then you go left or right. So if I go left, that's gonna subtract 20 as well, 28. Sorry. So then once I get to the end here,
okay.
Once you get to the end, if sum is 0, you found a path, right?
Okay.
So are you asking for all paths or just one path here?
I'm gonna ask you for all paths.
All paths, okay. Okay, so for that I would have to traverse the entire tree. How would I get to the leaves? Okay, so I'm thinking of maintaining some sort of list. No, do you want to maintain a list for this? Oh yeah, because you want the path at the end, right? Mm-hmm. So we want to maintain the list that we're or all the nodes that we've seen at least. So for example, in my example here, I do 10 and then I do 28. So at each point, I'm gonna have the path. Let's call it a current path,
mm-hmm.
and the current sum, right?
Okay.
So here by example, yeah. So I would start off. I'm at the root, right? So I have my current path is 10, right? And then my current sum, that's gonna be current sum. That's minus the node. So that's gonna be hold on. I need my initial sum.
Okay.
Okay. So
What's your initial sum?
my initial sum is 38, right? From the example, that's the sum that we want to find. Okay. So if I start off at I add this to my path. Let's say it's a list for this example. Current sum, that's gonna be 38 minus 10, so that's gonna be 28.
Sure.
So then I go to the left. Then that current path, that's gonna be 10 and 28, right?
Okay.
28. Your current sum is 28, and then 28 minus the current node, that's going to be 0. So so I have to check. I can have a sum 0 in the middle, right? Because you have negative numbers. So check if you are at a leaf. Check if you have sum equals 0. If so, add to result. Make a copy. The path or current path. Okay. Okay. So now, so you found your result, right? Now you have to think of a way. Is how are you gonna undo what you just did, right, to get to the very bottom? Because I have to explore both the left and right trees.
Okay.
So going back to this example, I'm at 28. It's a leaf node. There's nowhere else to.
Well, first of all, hold up. So in the example I gave you, there's two paths, right? One of them ends at 28, which is a leaf node, right? There's another one, 10, 13, 15, which does not end at a leaf node.
Okay. Oh shit. Okay, so. Okay, yeah, that was my assumption. So the sum, it can be anywhere in this tree, right? Basically.
Yep.
It does not have to end at the root node.
It has to end at the root because the problem is like from the root to the leaf. Oh, not root to the leaf, but like root to a node.
Oh, okay. So the problem says find the root to leaf with specified sum, right? So this includes any sum, right?
So it's the sum that I gave you, not any sum. The sum that I gave you. In this case, I gave you a sum of 38 in the example.
Okay. So in 10, 13, 15, right? That's a sum, right? Let's say there's more leaves below here where my current pointer is.
Okay.
And that adds up to 38. Is that a possibility as well?
Well, sure, I can add up to 38. Remember, there is a possibility here that if I go back to this example, right? Let's say 10, 13, 15, 24, and minus 24. You can also have this would also output 10, 13, 15, 24, and minus 24 as well.
Oh, okay. Okay, but your answer is going to always include the root from the problem description.
Sorry, what?
Your answer is always going to include the root, right? Because we're saying find the root.
It will always have the root.
Okay. Oh, shit. Okay. Okay, that makes sense. Okay, yeah, so I have to change this example then, because my initial assumption was that it would always end in the leaf node. Okay, so you check if it's a leaf. No, we don't need that anymore. Check. I guess my check to add the current path would be if you have a sum of 0, right?
Sure.
If you have a sum of 0, then you can add your current path.
Okay.
Okay. Make a copy of the current path. Okay. Okay, so let's see. Okay, so now I'm thinking is like when you go left and right. Okay. As you go left and right, you will have to pop off the stack. That means you have to clear the current path. Let me see. So I'm seeing so let's say have a 10 here, right?
Okay, where's the popping off the stack coming from?
That's like this is just my way of thinking. Like if I go 10, and this is just an arbitrary example. 10, 5, 5, 7. This is going all the way to the left, right? So if I pop off, because let's say I do this in a pre-order traversal. If I pop off once I reach my leaf node, I'll pop off the 3, and then I'll go to the right. Let's say there's a 7 there.
Okay.
So yeah, that's my reasoning there.
Okay.
Okay, so. Okay, so let me clean this up because it's a little confusing here.
Yeah.
Okay. Okay. Let's see. Okay, so let's say you will traverse the tree in a pre-order traversal. At each node, you will maintain a sum where you will subtract node.val. Okay, so at each node you will maintain a sum where you subtract node.val. Add node.val to a current path list. What else? If sum equals 0, copy this path to results. Okay. Okay, so at each node you'll maintain a sum. Okay, so traverse left, traverse right.
Okay.
So let me see. Let me just take this to. So yeah, I'm just gonna run through this quick example here.
Sure.
Make sure there's anything. Okay, so yeah. Okay, so. So okay, yeah. Let's keep a stack trace to track where we're at, or keep track of our variables, right?
Sure.
I have my current sum. I have my current. I have my current path, right? Okay. So I start off at the root node, right? So let me see. Current sum. Shit. Okay. So now. This is throwing me off. What is your starting sum? Starting sum, right? So then, what this idea is telling me is you're gonna traverse this tree in a pre-order traversal. At each node, you will maintain a sum where you subtract node.val. So my starting sum in this example is 38. My current sum is gonna be 38 minus the value at the root. So that's going to be 28, right? So then I'm going to add 10 to the current path. Sum is not 0. Oh, okay, yeah, current sum is not 0. Okay, so traverse to the left. What's that going to give me? I go to the left. At each node, you maintain the sum. So I subtract from current sum the node value. Node.val. So I see current sum equals 0. So what I do is result. That's gonna. Okay, yeah, I skipped a step. I did not add it to the current path, so I have to add it here. 28. The sum is 0. Current sum. Current sum is 0. Okay, so now copy this to your results. This is going to be a list. It's going to be 10, 28. Okay. So there, there's no left or right child for me to traverse.
Okay.
So by nature, I should. I'm at 28, right? So I visited the left. There's nothing there. I visited the right. There's nothing there. So since I called left on the node at 10, now I have to pop off those values, and I have to visit the right side of the tree.
Sure.
What that means is I have to pop off values from the current path.
Sure.
Okay. Okay. So here. Okay. Path.pop.
Sure.
Now I'm thinking. Okay, you have your sum, right? Your sum. Okay. Because you have the sum at that current node, and then when you go to the left or to the right, you subtract that value, and that's what you pass in. So if I go back up after following this traversal, I should have the value. What I mean by that is if I go, if I'm at 10, right? If I go to the left, I've already subtracted that value. So then I go back, I still have the initial value with 10, right? Which is 28. So then I go to the right with the value of 28 here.
Okay.
Okay. Yeah.
Well, okay, I see.
Okay, so, okay, yeah, so then I follow the same path here. I go to the right now, traverse left, traverse right, okay. Okay, so as I go to the right, let me just write these values in line. I have 10 and 13. Sum is, current sum is 28, and then I subtract 28 from 13. It's 15 now. It's still not 0. Let's say for this quick example, this does not exist here. Just for the sake of simplicity, I go to the right since this was null. I go to the right. I go to the right. So what do you have here? You have 10, 13. You have 10, 13, 15. Current sum is now 10 since wait, no. Current sum is now 0 because you subtracted the current value. So I see that we have 0 again, so I can add the current path to this value here. So it's 10, 13, and 15. Okay, so for the sake of example, let's say this doesn't exist.
Sure.
I go back 10, 13, 15, 24. Current sum is 24.
Okay, so you're basically saying this is null here, right? Okay.
Yep.
Why is current sum 24?
Okay, okay, yeah, yeah. That should be negative 24
Okay.
based on the design.
Okay.
Yeah, yeah. Negative 24. Okay. So then it's not 0, so there's nothing we can do here. So then we go back, we traverse down to the right side because there's nothing on the left. So my path is 10, 13, 15, 24. Current sum is now negative 24 minus negative 24. It's a 0. So then I see that it's a 0, so then I can add that to my result here. 10, 13, 15, 24. Okay. Okay, so I'm looking back at the idea. Did I miss anything?
Well, I think your idea works, so why don't you code it up?
Okay. Okay. Okay, so just gonna copy this to avoid the page scrolling.
Are you still at the bottom?
Yep, I'm
okay,
here.
Cool. Got it. Okay, go ahead.
Okay, so what is this called? Root to leaf with sum. Root to leaf with sum. I'm giving the root node, right? What else? I'm giving a sum, right? I'm giving a sum. So I'm going back to the top. What else am I given? The root of the tree, sum. Okay, and then I have a result that I want to output to. Results. Okay. Okay, so traverse and pre-order traversal. So data to code, then I do sum. This is what current sum results. It's just boilerplate stuff. Okay. Okay, so this is the important part. Okay, yeah. I need a current path as well. Current path. Okay. At each node, you will maintain a sum where you will subtract node.val, add node.val, add that to the current path list. Okay, so if not root, if not root, we're at the case where there's you're at the leaf and there's no left or right.
Okay.
So for that, you simply just return.
Okay.
At each node, maintain a sum where you will subtract node.val. So that means sum equals sum minus root.val.
Okay.
Add node.val to the current path list. Current path append. No, shit. Root.val. If sum equals 0, copy path to the results. If sum equals 0, okay, that's the right sum. Results append. Copy current path, right?
Okay.
Okay. And then you do traverse left and right. Okay.
Okay.
Then there's also the pop, right?
Okay.
Because you added something to your list, so pop off.
Okay.
Okay, so current path dot pop. This pops the last element from the list.
Sure. And
at the end, it should return you the results. Let me run this through a quick example.
Why the hell not? Yeah, okay.
Okay, so let's say 5, -4. Okay, so sum equals 10 initially. I'm going to subtract, let's see. Okay, so there, I'm right there. I'm at the root node. So sum becomes
Okay, I'm gonna say for the sake of time, let's stop it here because you pretty much have the right answer.
Okay.
Okay. So I kind of want you to think back what you did right, what you did wrong, and what you feel like you could have done better.
What I did wrong was I totally missed that you can add a value. You don't have to go all the way down to the leaf. So yeah, that confused me because it says find root to leaf, but specify sum. But after the example, I did not read that example there. I just jumped the gun and said, okay, we're gonna add values to our results once we go to the leaf nodes.
Okay.
I totally missed that case there. So I should have ran through the example there and say, okay, 10, 13, 15. Okay, that tells me that I don't have to be at the leaf nodes.
Okay. Pretty much, it boils down to scoping. I'll paste my notes here, but basically, the first 13 minutes were pretty much a mess because you didn't, like I said, you got confused because you didn't scope and the reason why is because you didn't scope the problem. You didn't realize what you were responsible for, what you're not responsible for, and what the parameters of the problem were. And like, hey, is there, if you think about it again, if you think about it from the perspective of like bulletproofing and punching holes, it's like, is there any way I can misinterpret the problem? And that's usually the best way to figure out, hey, let me throw some examples at it. Let me figure out, hey, is this what happens if I do this example? Let me just clarify everything. So if you think, again, it goes back to the whole, is there any way I can misinterpret this or is there any way I can go wrong? And you kind of, again, you jumped the gun because you assumed certain things. And all I literally said was, look at the example, look at the problem, you know? And this is like the happy case where the person's kind of giving you the example. Whereas, and giving you kind of a complete example, really. Whereas, what happens if I didn't? So, for instance, what if I never told you about the negative number? I mean, I admittedly told you that, but what happens if I did? Would that a thought have occurred to you?
Yeah, no, I would have missed it totally.
Yeah. In other words, you need to be more like you need to be able to be aware of the different ways you can misinterpret problems like these. That goes back to the whole punching holes in the. In your thing. And so what really saved you is the fact that at 13 minutes you've decided, screw it, let me do an example. And that basically took as like, 5 minutes, that's really easy. The pop thing came out of nowhere, really. And that's why I was like, wait, why the hell are you popping? So the overall, what needs to happen is that even though you got the right answer in a okay amount of time, you need to be much more logical about this and the approach has to be much more streamlined. It has to be, okay, what is the scope of the problem, right? Then let me do an example of what I think, just to double check it, right? Then after that, let me handle the null case, the single node case, the node with 1 children and 2 children case. What do I expect going into the node? What do I expect coming out of the node, etc., etc. And so when you say pop, it's like, okay, well, the more specific idea is backtracking, but yeah, it's like, once I have committed, once I've found the answer, I've sent the list down, and I get it back out, I'm going to undo whatever I've added in the list. That's the way you should be like presenting it. It should be like very militant, very logical, talk, you know? And you kind of meandered and then you came together with it. So that probably cost you around like 3 to 5 minutes. So that
so
go ahead.
So when I do the example, that's when I should have mentioned, okay, this is when we'll pop off our path, right? Because you said it came out of nowhere.
It came a little bit out of nowhere because I wasn't sure. Like you randomly called out the popping off, and I'm like, wait, what are you doing here?
Okay.
You need to describe the top level idea of why this exists to begin with. If you think of we're going to traverse into left node, right node, why are we traversing into left node, right node for now? Because, and then you can say, it's because we're going to pass in the path so far, and when we go, and by definition of the function, we're going to process the path so far plus the node that we're currently at, and then evaluate whether or not it's an answer we want to give. Do you see how logical and simple that was?
Yeah.
You need to be able to do that. Everything needs to be logical. Everything needs to be as close as logical and as succinct as possible. And I think if you watch the replay, you'll understand what I'm talking about. But I think you kind of had a hint of like, I kind of meandered for the first 13, 15 minutes.
Yeah.
So that needs to be tightened up. And if you tighten that up, your approach and code will be a lot better.
Cool.
So other than that, just get a little bit more comfortable with recursion. I can tell you're not super comfortable.
Yeah. Because with these problems, like I mostly do them in pen and paper.
Yeah.
Once here, it's kind of like hard to do the stack trace, and yeah, so I have to practice more on this. So
Stack
that's
trace.
why I did it the front lot.
Yeah, you kind of. It's like I get it, right? But at the same time, all these problems and all these interviews are conducted on Zoom, so you better be fluid.
Yeah. Oh yeah. For sure.
And then it's also the logic of the thoughts that you need to express.
Okay.
So it's not just pen and paper. It's the logic there, and that's what I'm kind of harping on. The pen and paper is just a consequence of that. So.
Okay.
Other than that, there's like a few other nitpicks I've written in there, but other than that, it's fine. I think.
Okay.
Okay, so let me go ahead and pull up a system design problem. Yeah, we have time to do one, I think. So let me go to Excalidraw. Let me share with you. Via Zoom. Got it?
Yep.
Let me know if you need me to drop in some assets as well.
Let me see. Let me open this. Okay, yeah. Here we go.
Okay, so let's see. Message queue, Trondra. Okay. Alright, let me go pull this up, and then here we go. So I want you to design a cron job scheduler. You're familiar with cron, right?
Yeah, it's like let me see. Just by example, it has like some values like this, right? And then it has like MV.
Okay, well, what does cron do? Let me ask you.
A cron, what a cron does is it's a scheduler, right? So you can schedule jobs 1 month ahead of time. You can schedule jobs to run every minute, every second, and at that particular time, it's gonna run some piece of code.
Yep.
Or yeah.
Okay, that's fine. Yeah, you understand what it is. Okay.
Okay. Okay. Cron job scheduler. For this, do we want it in a UI? Is it gonna be a command line application?
Just consider the system itself. We'll do the interface afterwards or later if we have time. But
okay, so user should be able to submit cron jobs.
Okay.
And schedule, right? Something like that. Is that the right path?
Sure. Why not? Yeah.
Okay. What else? Okay, so I'm thinking, do you want to keep this in like a database, or is it just going to be a file that's constantly read? I guess my question is like, I guess I'm thinking too ahead of here. Is this going to live in like a UI, or you just want a simple interface, right?
Again, don't worry about the interface. It could be command line, it could be UI, it could be whatever. Focus on the system.
Okay. Okay, so user should be able to submit cron job and schedule. User should be able to remove jobs. User should be able to edit schedule, right? What else? I should be able to submit cron job schedule, remove jobs, edit schedule. What else? Is this something that's gonna run like in a distributed machine, or is it just gonna live in like one system, right?
It's gonna distributed machine. It depends on what scale is that you're working with.
Okay, so I'm just gonna draw a quick example to explain this. So say I have a user, right? Then I have like the server, right? You can have like some sort of scheduler here. Let me see. I'm looking for the server. Okay, yeah. Yeah. So this is just saying the user is able to submit their cron job and schedule that gets saved to the server, right?
Mm-hmm.
The user can remove jobs that gets modified here in the server. It's still not clear though, like if that should live in a database
Well,
or
what is living in the database? Why do you need a database?
what should live in the database is you have individual cron entries, right? There you can have like the time it runs, and then you can have the specific command to run.
Okay.
So from thinking about this, you can have this in a file.
First of all, what makes you think that it's a command? Why is it not a script?
Okay. Okay, yeah.
Because if you just run script.sh, right? That a script, technically that is a command, but you also have a script as well, so.
Correct. Okay. Leadership with semi-cron jobs. Okay. Yeah. So should be highly available. What else? Yeah, man, this is a hard one because I'm thinking, okay. Okay, yeah. So the way I'm reasoning about this in the non-functional requirements is like, okay, whether to choose CP and AP. If I choose CP, right, that means that the data is going to be consistent for everyone, which is what you want for a cron job, for a cron scheduler. If you reason it where the data can eventually show up, I don't think that's the right approach.
Okay.
Because this is something that has to be pretty damn accurate. You can't afford to. Okay. You can't afford margins on error on this, right? Because you can have a command that can delete scripts or at specified times. So, so choose a CP based on the fact that we will that we care that users see the same data. Okay. As far as metrics, let's see. Okay, so kind of a little we choose CP. Now the thing is this gonna run like across multiple machines? I'm basically trying to get a scale of the. I'm trying to get a sense of the scale here.
Okay. Let's simplify for now and assume that all the machines are homogeneous.
Okay, all the machines are homogeneous. Okay. Okay. Okay, so let's say. Okay, let's thinking about numbers here. Let's say there's 1 million jobs a month, right? No, sorry, 100 million jobs a month. Okay. Trying to get a sense of how many jobs are going to run each second, right?
Okay.
Okay, so I guess the heuristic I have for this is you divide by 3 million, right? Then you get how many jobs run per second.
Okay.
That's like 30.3. Let's say it's 33 jobs per second, right?
That's okay. That's okay. That's a little low, but all right.
So I'm thinking here, you don't really have to store anything because these scripts they can live somewhere else, right? You basically just have a cron that runs code.
Sure.
Or scripts.
Sure.
So I would say the throughput, and throughput scalability is our main concern here.
Okay. When you say throughput and scalability, what do you mean?
What I mean is by throughput is like you have all these jobs. We can't afford for the system to go down at any point.
Sure,
Because we
but what is the
expect these
what throughput are you talking about? Let's be very specific.
the 33 jobs per second.
Okay, so you think that we might is this the amount of jobs that users are creating or the jobs that are run?
These are the jobs that would run.
Okay.
Yeah.
Hey, you're gonna be way more. Just as the coach note, be way more specific because notice from this side there are two sources of throughput, right? So you gotta be way more specific.
Okay. Wait. So if I do the read-write ratio, people are going to be running more jobs than creating them.
Okay. Yeah. That's okay. That's reasonable.
Mm-hmm. So. Okay. Shit. Okay. Okay. So I have 33 jobs per second, right? That's how many jobs are running. But then, how does that affect your reading, right? 33 jobs per second. How many jobs? Okay. Shit. Okay. So I would say it's a 1-to-1 here, right? Because you have these jobs running. It's not like people are going to be reading. It's not like you can't look at this like the social media site, right?
Okay.
A job is going to execute one piece of code, right?
Sure.
Not two. So okay. So reason it that way.
Okay. So the jobs themselves are gonna be reading as much as they're writing, or is it the end user that's gonna be doing it?
These are how many jobs we'll be running. Let's say, yeah, if we look at that point of view, right? Like a user is gonna create a job, it's gonna be ran more times than it's created. So by that argument, let's say
the jobs that are created or run, and you're talking about the user now, right? Or
yeah,
okay,
correct.
So talking about the user.
Mm-hmm. Yeah. So let me see. Okay, so yeah. So a user adds a job. That job, it's really hard to say because these crons can live forever, basically.
Sure.
It can be ran many times. You can't say like, oh, it's going to be ran 100 times. So that, yeah. This is yeah, it's like infinite, right? And then it's like a 1-to infinite ratio because you don't know. We don't know ahead of time how long our company can be running these jobs for.
Sure. Sure. In other words, the amount you're basically comparing the read-write, you're actually comparing the writes, the creations of the jobs of the user versus the runs of the jobs themselves. That's really what you're comparing.
Correct. Yes.
Okay.
Okay. So. Yeah. Let's say like a very simple example, the user submits a job to the application server. It submits a job to the server that gets saved into a cron file or a cron database, and it updates the cron scheduler. Also, the user can ping the server. It can delete certain entries, and it can also edit a specific entry on the cron job. Okay, so what's the obvious pain point? The obvious pain point is we're gonna have to support this for millions of jobs, right? We're running 100 million jobs per month.
Okay.
So let's say let's see 1 second. Yeah, this is just for the sake of example. Let's say we're maintaining this in a file, right? It's just a cron file.
Okay.
So the idea with that is there's a lot of users that can be painting your server and writing to one file.
Okay.
The file can be locked when the user is editing the file.
Okay.
That's a bad experience for users. So let's think of something different, right? that's not, yeah. So that I don't want to use that approach because it can lock a file, right? So let's say we save these entries into a database, right? Um, if we save them to a database, we can have users add in a bunch of rows, right? You can also have users saving or editing the cron files. Okay. So let's say there's a user, username, etc. Then there's a cron job, right? It's gonna have your cron schedule. This is the command to run. Let's say we have a disabled, enabled flag. What else?
Okay, so you have cron job, cron schedule, command. Okay, enable, disabled. Okay.
What else? So I'm thinking here. There's really no joins that are going to happen here. Or sorry, there should be a relationship on who created this cron job, right?
Oh yeah.
So let's say a user that creates a cron job, they can edit their own job.
Okay.
I have my cron schedule. Okay, so there's gotta be a let's say I have a machine, right? It's let's say I have a service, right? It's called the cron runner.
Okay.
Cron runner. Okay, the database should be updating this, right? If there's new jobs being edited, that should modify this specific cron.
Okay.
What else? Okay, so let me see. Okay, so I covered the case where I can edit, I can remove jobs, and I can submit. So okay, so going to the first case, I submit a job. It goes to the server. That gets saved to this database. There's going to be a scheduler that updates the cron runner based on any diffs that happen between the cron runner and the database. I'm able to remove a job from. I can disable it from the cron job table. That updates the cron runner. I can also edit the schedule through the same path. What else? Should be highly available. Okay, what else? So if I throw a bunch of users at this, right? What's gonna be my first choke point, right? My first choke point is that I only have one database, right? And this is gonna handle all these millions of jobs.
Mm-hmm.
What else? Okay, so if I have this table, right? I have this database. Okay, how can I handle? So now, let's say we have a backup, right? In case this database dies, there's a replica that can take place, right?
So let's first ask. You've been spending a lot of time like trying to handle the database portion of this. My question now is that, well, why is the database more important here? Because you still really haven't explained like the flow of the system to me. Mm-hmm. All you've done is say, oh, we have databases that list a bunch of jobs. And how does your system work?
Okay, so the way my system works is this cron runner, it's gonna be ran against various machines and execute commands, right? So this cron runner has to be ran inside a certain machine, right? And it can execute commands, right? So I'm thinking like, should we introduce various machines where we can run these commands? for the simple case, let's just stick to one machine, right? So this cron runner runs on a schedule, and then it's gonna execute commands, right?
Okay.
So let's say this is yeah, let's say you have a server, right?
Okay.
Yeah, the cron runner basically it's just going to execute commands against the machine, right?
Okay, sure.
So it's going to be constantly running.
So what if your cron runner just executes commands? What the heck is it doing talking to the database?
The database is just there to maintain state on the cron.
Okay.
On the cron address schedule.
But it's attached to the runner itself. So what exactly is this cron runner doing? Is it going to be querying the database?
No, the cron runner is going to be your actual cron tab file.
Okay, so then why does it have a relation to the database if it's not going to do anything with it?
Oh, okay, yeah, that makes sense. Yeah, so the database should not update the cron runner. What should happen is that should come in through the application server, and that's where your cron gets updated. Yeah.
So it's okay. So your server then updates the. Okay, sure.
Yeah. So then your cron runner is going to be running, and it's going to be sending commands to your server. Sure. For example, it can have a command to move files, etc., delete files.
Okay, so you have another server for actually executing the stuff. Okay.
Correct. I guess I can put it in. Does that make sense though? Because usually the crons run inside the machines where they execute the code, right?
Sure. So
why not say your cron is gonna live inside this server, this machine, right? Inside this machine.
Okay.
And it's just gonna be a cron tab that's constantly running based on a file that's in the cron tab file.
Sure, fine, whatever. But then, okay, so then how do you plan on scaling this out? Because one machine can't handle all that power, right?
Yeah, so, okay, let's say this is not a cron runner, right? But it's like a cron updater, right? Or a cron service, right? The cron service that handles updates, deletions, and modifications of the cron file. To scale this out is okay. First, we have to say, okay, is the data going to be is the data homogeneous in the server?
Okay.
Meaning, can it be copied over and basically create a replica? If so, let's.
But the server is only used for execution, right? So what is this replica thing?
So the server is used to execute code, right?
Okay.
You're just executing one piece of code, right? And this piece of code, right? It can touch various databases and whatnot. So essentially, it's just servers that communicate with your machine to run the code.
Okay.
Let me see. Yeah. So for that, I would just have multiple servers, right? To run this code against, right? Like if one server is too busy, you can send off the same. You can send the same off. You also have to make sure that you don't run the same cron file in one in two separate servers, basically.
Okay. Yes, that's true.
So that's one thing to consider here. So if I have a cron that's running in one single machine, that just sends commands to execute. What's really important is not the service itself, is actually having this cron service. We don't want, let's say in case it goes down, right? You're going to have like a standby machine.
Okay.
that can take its place. You have to be really careful, however, because if you run two cron services at the same time, it can be really bad.
Okay.
You're talking about executing the same command in the same command multiple times across servers, right?
Okay.
Yeah. So yeah, given that the servers, we can scale these up because it's just running code against them.
Okay.
We
How do you know that? Well,
Okay,
okay, I get the idea. You have some central cron service that sends off to servers to execute. How do you know when the job is done then?
Okay, so I'm thinking, okay, a cron tab, it just has a function to execute, right? So why don't we take this a step further, right?
And not to mention, how do you plan on distributing this?
Okay. Okay. Okay, so I'm thinking here, how do you know a job is done, right? Let's say we keep, keep some state of the status of your jobs, right? Is your job running? Did it complete, right? Oh, 1 second. Job run, right? State, is it running? Is it complete? Did it fail, right? Okay. So every execution should have a job run entry. And that's to track, did I job finish? Is it still running or did it fail, right? Let's see. Okay, so I would have to maintain this state. So I'm thinking where to put this, right? I have my job run.
Okay.
That's going to have to live inside the machine that's actually running, right?
Okay.
So yeah, because you don't want this. Oh yeah. Okay. So this would also take care of the case where no two job runs can run at the same time, right? Because say I'm trying to execute a cron command against a server. I'm first going to check into this table. Is this current cron running at the moment? If it is, ignore that. If it's not, you can run the job, right? Also, if you want, how do you want to handle jobs that previously failed, right? This is up for discussion. Do you want to leave it up to the user so they can manually recover and look at the logs that happened from the last fail? Or do you just want to keep running it until you build up your log queue, basically?
Okay, so you're talking about the failure condition. So what happens if a job fails? What do you want to do?
Oh, okay, yeah, that's a good one. It depends, right? Like, there's some jobs. Okay, so I'm thinking this out. There's some jobs that are okay. There's some jobs that are gonna fail once in a while, right? Let's say it's email sending, right? Then there's jobs that you don't want to fail or you should really look into, right? Like, if it's inserting like a million queries into your database, you definitely want to take a look at that, right?
Okay, sure.
So I would say maintaining some sort of priority on the job run, and that would tell me whether to rerun or not based on the failure condition. So
I'm actually going to stop you here for the sake of time.
Okay.
So I kind of want to hear your feedback on what you think you did right, what you think you did wrong.
Oh man, yeah. Yeah, I think I got stuck here, like, because this problem is really outside what I've been doing for so long. Like, you have a system, right?
Okay.
But then if you talk about, like, okay, you want to scale out a cron a cron that runs it like a Linux machine or something, right?
Yep.
Like, okay, how do you apply the read-write ratio? How do you apply your metrics?
Yep.
Yeah. That's basically what threw me off there at first. That's why I spent so long in like the functional and non-functional requirements.
Okay, so identify the problem here is that you basically copy pasta your approach from grokking. And I deliberately threw this problem at you to test your problem solving approach. So what you did with your functional non-functional requirements is not wrong. What you did do wrong is that you ignored the user story. And if you focused more and made that a priority rather than your check, I mean, this is the part where like, hey, yeah, you're doing your checklist, but part of that checklist is the user story rather than the checklist for its own sake. That's it's a very subtle difference, but it's a very big one. What do I mean by this? So in other words, if you had just thrown a user at the problem and what the system user expects and the system expects and how it responds, you might have come up with a lot of the points that you did before, a lot simpler. So for instance, if a user schedules a job, say, hey, I want to ping Google every night at 12 a.m. or 12 p.m. or some shit like that, then I'm going to write a job that does that, right? And then I myself like, okay, ping Google, ping Facebook, ping Yahoo, ping whatever. So one user can have 10 jobs that run periodically, right? And so the amount of ratios of users to jobs is actually going to be probably one of the ratios you're going to want to look at. Another way to look at it is how many jobs are run per hour per second. So 33 jobs per second is a little bit low because, well, if I have a scale out machine, like let's say I'm working at Facebook or Google, there's going to be a lot more than 33 jobs per second across the company.
Yeah.
So that's another thing you're going to want to think about. So in other words, it's not the number of user interactions here that is the problem. It's the number of jobs that are run per second.
Mm-hmm.
So in other words, what can go wrong? What's the source of our grief? In this case, it's not the user. The user, the Kanye West example has worked very well because it is, a lot of these systems that we've been working with are effectively user-centric. In this case, it's not the user that's the core problem. It's the number of jobs you run that's the core problem. Yeah. Now, you were able to kind of finagle and realize, hey, you're going to need to have a master-slave configuration for the cron service and the servers, which is basically in line with a master-slave configuration for executors. The one thing that kind of irked me was the fact that you went straight to the database. And I'm like, huh? Okay. In theory, if these jobs are super simple, almost all of them can live in the... the memory. Like back in the envelope calculation. Let's say I'm only doing like a one-line command. And let's say the one-liner is, 50 bytes. Just to recommend 50 strings, right? 50 characters. And then you have a Unix timestamp, which could be a long, which is 64 bytes. So what? That's 110 bytes. Let's say 100 bytes. And then let's say we have a few gigabytes of memory. What? That's like 10,000 jobs right there? Mm-hmm. Yeah, 1 gigabyte is 10,000 jobs. So in other words, and then we can hold those in memory. So that's actually doesn't. So if you think about it, we can slam it with 200 gigabytes. So what? 300. So that's 3 million jobs we can handle at a time. So with just 300 gigabytes of a server. So really, all this in theory could live in memory. Mm-hmm. And so just based on that back in the envelope calculation, of course we want to scale it out. That's when we come to the database. But I would have tried to just do the simple case first, which is just that, right? That back in the envelope thing I just did in the back of my head. Mm-hmm. Mm-hmm. And I would have said all this can live in memory. All these things can be a database, in-memory database. So I might even use Redis or whatever, key value storage, or maybe not a key value store, maybe something that's chronologically ordered. And keep all the cron scheduling in memory. Of course, now, handle failure. Let's use a SQL in order to handle the job ID, the user that created it, command, But I would not keep the job and user separate. The reason why is because the only thing that matters here, again, is the job, not the user. So, in other words, I could fit this all into one database. And you kind of touched on it. You kind of hinted at it, actually, with the join. It's like, we're going to want to know the user that created the job. But really, because you focused on the user, you had the other way around. Again, the thing that's going to drive this shit is the jobs. So you would have the job ID, user ID, and then if you thought about, I need to know if it's running, waiting, or scheduled, then you would basically have that as your status. That's the bare minimum. And then you would have the command as well. And then say, okay, let's assume now, simple case, that the command is something that can fit into 50 bytes. And then later on, we can figure out if we want to have the file system. Because I think we start very simple, right, with a lot of these things. Because the job itself, not the user, is the core. We just want to make sure that we can execute any job. So it could be like an echo command or a ping command or whatever. Fuck. We want to handle the simple shit first before we handle the complex shit.
Okay.
So, and that's kind of like what you missed out on. And so now it's like, okay, well, if we have a simple ping commands, well, we're going to need to have a lot of executors to do that. Because, like I said, the 10,000 or 100,000 or whatever number of jobs that you have per second, you basically send those off to servers, right? And then you have executors that are going to execute the job for you. And then how do you select those jobs? You can do round robin, you can do weighted partitioning, you can do weighted chip picking or whatever. And then now how do you handle the failures? Okay, well, we're just gonna have some exit code. It's gonna be up to the user to determine the exit code. And all you need to do is just have a system log. So every run that's done writes the system log and then saves that system log and then writes back. And then when the cron service gets a return back from the server or whatever, the server just then returns that to the database saying, hey, this job was done. Something pretty simple. In fact, let me just paste the one of the solutions that I have. So let's see. Insert image. Hold up. Actually, I'll just paste it in your prep doc or your problem sheet.
Sounds good.
This one. So you basically kind of see like how I was able to derive it. This is one of many different ones, but the problem you had here was that you incorrectly identified your source of pain, and then you kind of like screwed up. It's like if you've ever seen how Jenkins actually works, and I'm pretty sure you're familiar with Jenkins, it's basically modeled off of that. Except except this is like way more simplified.
Yeah. Okay.
So in other words, I would recommend, and let me paste the notes I have here with this shit. I recommend you rewatch it. Basically, you lost sight of the most important thing. And because you adhere to the it's like that you kind of turn off your brain and just assumed, oh, let me just blindly copy paste my approach from past experiences from grokking, right?
Exactly,
that's the problem. You weren't thinking critically about like what's the pain points, what the question I need to ask myself. Your checklist was way too tailored to the social media whatever fucking problems.
Oh yeah, Instagram, Facebook.
Way too tailored.
Yeah.
Be more flexible. Be more flexible with your problem solving.
Okay.
So, that's my feedback to you. I think for homework, keep at what you're doing, but keep in mind the mistakes that you've made today. I think that the big thing you're going to need to talk about and think about is one, bulletproofing the scope of your approach for data structures and algorithms. Thinking about, hey, I have this idea. What can go wrong? Same thing with system design. Now I have this idea. What is the pain point? What is the thing that can go wrong here? What is the most important thing? It's almost always that question. What is the most important thing that's going to cause me the most pain? And again, you can transfer that question over to data structures and algorithms as well. And the second one is I would recommend you start looking at scoping. I don't know if you do this in your job, but you scoped pretty terribly when it came to a lot of these problems. Like you didn't understand, what am I responsible for? What am I not responsible for? What do I have to think about? What do I not have to think about? Functional and non-functional requirements are just a way of managing that. But you should think of it in terms of servicing what you need to address, what you don't need to address, or what might be nice to address, and so on and so forth. This is something I want you to pay attention to, is that am I properly defining the boundaries of the problem? And that's super important if you want to secure the L5 offer. Any senior engineer is expected to do that. And you kind of showed that you weren't able to do it. So I would highly recommend you think in terms of limiting the problem to things that are manageable. Does that make sense?
Okay. Yeah, that makes sense.
Okay. Any final questions?
Okay, so for the homework, is there chapters you want me to go over? Because I remember the last section you gave me strings, recursion, and trees. Is there specific chapters on API you want me to go over?
I want you to really focus on recursion because you kind of fucked up here really badly with like recursion. I have no idea how the fuck you got the right answer. I mean, I guess you had the bare basics of the right approach, which saved your ass, which has been a common theme. So what you need to do is like clean up the first 10-15 minutes and how you approach that shit.
Okay, the recursion approach. Okay.
A recursion approach. Make sure your logic is bulletproof, and make sure it's every step, everything you say makes more sense, and is derived from the previous thought you had.
Okay, and everything you say basically has to show up in the idea, right? Like the pop-off or how it came out of nowhere.
Yeah, if you ever look at your fucking like replays and you say, where the fuck did this idea come from? Big red flag.
Yeah. Okay.
All right.
Cool. So you said Google aim it for the end of October then?
Aim for the end of October, yeah. I think.
Okay.
I'm honestly, I'm 50-50 as to whether or not you're going to make it by end of October, but we'll see.
Okay, and also you said to remind you about the Reddit note.
Oh yeah. Let me pull that up and I'll link it in the chat for you guys as well. So let me Yeah, hold up, give me a sec. While I'm still here. YouTube, Reddit, what is it? InfoSec or InfoQ, I think. Evolution of Reddit, scaling at Reddit. Was that it? Evolution. Let me see.
Or storing those cache. So I meant.
Yeah. Literally cache queries.
Cache.
Is it?
And when you're taking
or
over
cache
this amount.
queues. Hold up.
That was a bit about. And I decided with the secondary, it created the thing, and we write it. To
I
cache.
think this is it. Let me watch it and let me know if it makes sense. But this is the one. I'll send it to you in Zoom. God, I know for sure it's this particular channel. Let's see, Reddit, info, what was it? InfoQ. The evolution of Reddit.com's architecture, I think. Scale at Reddit. How Slack works.
Show of hands, who here has heard of...
I think that's it. I think this is it, yeah. Oh, even observable distributed systems. Actually, yeah, if you look at this, the first 1, 2, 3, 4, 5, 6, 7 are all really good, actually. And guys, in the chat, I would recommend you actually look at all the things from InfoQ. If you notice, like, even how does Slack work is also a really good one. I think you would get a lot of benefit from.
Okay.
I'm pretty sure I've watched at least half of their videos, now that I think about it. Oh. Okay, anyway, yeah, I would recommend you watch those, kind of get a sense of how other teams handle similar problems, and what their considerations were. Maybe try to reverse engineer their thinking. And most importantly, pay attention to the ways they've crashed. Because that's, like, there's a very good saying by Charlie Munger. I want to know where I'm going to die so I never go there. That's literally a lot of the system design is, hey, I recognize going down this route will get me killed XYZ place. So,
Okay.
all right. Any final questions?
Well, awesome. Nope, that's it.
All right, sounds good. I will see you Thursday.
Okay, awesome. Thanks, man.
All right, take care. Bye-bye. All right, let's see what people say in the chat. Use Discord for fantasy football right now. Very nice. 450 per session. Yeah, no, it's excellent. I'm glad you found a lot of value, man. I appreciate that. How did I message you on Discord? What's my Discord ID? It's Edbert. You roasted me way worse than this guy. Yeah, because I don't exactly want me being a fucking douchebag going online. I mean, I'm kind of like that already, you know, and this is like the politically correct version. I mean, I didn't really swear that much. But me being like a kind of a hard ass, I'll do that more in private. But I don't exactly want someone from the internet clipping me and being like, oh my god, this is an Uber employee who is being a fucking dick to this random guy on the internet. Not exactly a great look for me. I mean, it's more closer to me than, like I said, these are just manners. Let's put it that way. But I admit, like, just being harsh and honest with people is a lot better. I will say that. Good stuff, man. I learned something. I'm glad you learned something, man. I'm glad you found this session useful. I have a question. In my on-site for early career software engineering in some time in December, would I be a good candidate to take on for long-term coaching? Okay, I'm going to tell you right now, my long-term coaching is actually kind of closed right now. And there's a few reasons for that. One, I really haven't heard back from Jay's Google thing, and so I'm keeping that on ice. You know, I try to do ride or die policies for people. You know, if I am invested in someone's success, I try to stay with the course with them until I don't think they're making progress or whatnot. And I think that Jay's putting in the effort, so I have no reason to drop him, even if we don't make the Google. I mean, granted, this was like 3 months of me pulling my fucking hair out, and we only had one shot, and it's stressful as fuck. But, you know, I'm sticking with my principles. So, you know, I could drop him and rotate to someone else, but I'm going to say no because, you know, there's no reason to. He's working hard on it. He's, you know, he is definitely trying to make progress, and I respect that. So there's no reason for me to want to do that. So I will send out an email when I'm ready to take on new clients, but to be honest, it's closed off right now. I even have some people in queue as well. Well, everyone's laughing in chat. Yeah, don't worry. I'm only going to be like a dick if I'm really pissed off. And right now, I mean, I'm not really pissed off right now. So that's what I got for you guys. Any other questions? But yeah, by the way, guys, this is what I'm referring to, InfoQ. I really recommend you guys like subscribe to this channel. They have a lot of fucking good talks here. These are real people, like staff and principal engineers, who basically talk about like different ways that they've fixed problems in their architecture, and it's a really, really good for learning system design, I think, because you're not necessarily learning one way to do things. You're learning what the trade-offs are between doing one thing one way and another. So, for instance, that Reddit thing, right? What is the perils of having a backup queue database? And I'll leave that for you guys to watch. And there's also like things from like an operational perspective as well that you might not actually think about. So everyone thinks that, oh yeah, cache, database, and whatever. But then there's another angle that a lot of people don't really ask or answer, is about, hey, what does it take to maintain this system? How many man hours are we going to need? What's the likelihood of failure? And what's that going to cost the organization? I think when you really, really start doing this shit, and you start managing infrastructure, you really start asking some of the weird questions that are not in books. And this is why I say system design is not any different from data structure and algorithms. The only difference is a source of information, whereas data structure and algorithms is more finite. System design is infinite because there's many different ways of doing things and many different ways of blowing yourself up. But the fastest way to get good at system design is to know not like how to do things, but how not to do things. And you just start collecting those. Eventually you start getting a hint of like, hey, yeah, if I go down this route, I get a sense of this is going to be fucking hard because, Reddit blew themselves up this way, and Facebook blew themselves up this way. Oh, if I go down this route, this is like how XYZ did it. And, you can always bring these up during fucking interviews as well. And so, therefore, you can just go by the heuristic of what's least likely to blow me up. Or just start simple, So, it's that sort of exercise. You just need to kind of like ram your head against the wall against that. And then eventually your knowledge it'll start clicking. So, with that, I think no one else is asking any questions. So I'm going to turn off the stream for tonight. Thank you all for joining me. We'll be back Thursday at 8 p.m. Pacific Standard Time, unless I'm getting a question from my Discord. Oh yeah, join the Discord. I'll be on there most frequently. You can also contact me on Twitter. Find me for coaching at eChantech.com. Other than that, thank you all for joining me. See you Thursday, 8 p.m. Pacific Standard Time, and have a good night.